We will learn how to solve proportions and how to use proportions to solve problems involving similar triangles.
Proportions and similar triangles. Logical evolution. In the beginning, we will talk about proportions, how to write proportions, and how to solve proportions. After that, we will move to similar triangles, and we will use proportion in order to solve problems about similar triangles. And then we will move to word problems where we have to use proportions and similar triangles in order to solve a problem.
Ratio and proportion first, and then we will talk about cross product. Modeling. Basketball game. Two teams, monkeys and foxes. And score is 80 to 60, or we can say ratio is 80 to 60. Instead of word 2, we will use two dots, similar to division. Or we can use fraction bar, 80 over 60. This is what we would call ratio. One more modeling example. Cornbread muffins recipe require 3 eggs to 2 cups of cornmeal. So we can show this as a ratio 3 to 2 or 3 over 2. But if we have a big party, maybe we need 2 sets of cornbread muffins. So we have to have 6 eggs to 4 cups of cornmeal. Ratio is 6 to 4 or 6 over 4. Now let's talk what we saw in previous 2 slides. First slide show ratio 3 eggs to 2 cups of cornmeal, or 3 over 2. And next slide show ratio 6 eggs to 4 cups of cornmeal, or 6 to 4. But in both of them, what do we see? For each 3 eggs, we have 2 cups of cornmeal. Now, if we compare these two ratios, 3 over 2 and 6 over 4, they are equal because they show the relations between eggs and cups of cornmeal. For each 3 eggs, we have 2 cups of cornmeal. If two ratios are equal, then we would say they are in proportion, or we could say they are proportional. Now let's look for very special property of proportions, cross product. If you multiply 2 times 6 and then 3 times 4, you see this? Left side, it looks like equal to right side. Let's check, is it true or not? 2 times 6, 12, and 3 times 4, 12. Yes, this is true. So what we can say? Cross product. When you're multiplying cross product, you are getting left side and right side, and they're equal. Parts of proportions can be unknown, and we can mark them as a variable. So then you will see proportion, it's not something special, it's just shortcut for an equation. And we need to solve an equation, and we will use property of proportion, cross product. So let's multiply 2 times 6 and then 3 times x. Simplifying 12 equal 3x. Now we are looking for x. We have to divide it by 3 both sides, and x is just 4. As you see, we use cross product in order to solve this equation, because this equation is just a proportion. Now another part of proportion is unknown, and we are going to use cross product in order to solve this equation. It will be 2 times x equal to 3 times 4. Simplifying, 2x equal 12. Now we are looking just for 1x, so we have to divide it by 2, and x would be just 6. If an equation is in the form of proportion, we can use cross product in order to solve even more complicated equation like this one. So what we will have 2 times x, 2x, and then 4 times x and positive 1. But if numerator or denominator has more than one term, please use parentheses, otherwise you will make a mistake. Now, in order to solve this equation, we need to use distributive property in order to remove parentheses. So it will be 4 times x, positive 4x. Positive 4 times positive 1 would be positive 4. Next step, we have to separate terms with variable and constant terms. Let's move positive 4x from the right to the left, and it's becoming negative 4x on the left. Next, we have to simplify negative 4x, and positive 2x will be negative 2x equal positive 4. And because we are looking for positive 1x, we have to divide it by negative 2 both sides, and we will have x equal negative 2. We're done.
Solving word problems. Most word problems require equations. Let's talk about logical path for solving word problems. You have to read problem entirely. Get a feel for the whole problem. It's important to understand what the problem is asking, what exactly is the question you need to answer. After that, let's talk about first step, analysis. You have to pick a variable to stand for unknowns, clearly labeling these variables with what they stand for. After that, read the problem again in order to recognize quantities and the relations between them, between numerical values and variables. Look for keywords. After that, you will be ready to translate the word problems into equation with variables. And then you have to solve this problem. It's important to check your work as you go, and after you finish, you make sure you are getting the result that makes sense. And finally, you are ready to write the answer. But please remember, to really learn how to do word problems, you have to practice more and more and more and more.
Practical approach. It takes Chuck 20 minutes to type and spell check 14 pages. Find how many pages he can type and spell check in 4.5 hours. So the question is, how many pages? Number of pages is unknown. Analysis. I am trying to solve problems like this one from the end. I am trying to read the question. Find how many pages he can type and spell check in 4.5 hours. So now, number of pages is unknown. I will mark as a X. And time is 4.5 hours. Looking into problem, I can see that ratio of pages to the time in minutes is 14 to 20. And if I would make an assumption that this ratio pages to times is the same for this person, then I can say that everything is in proportion. But the problem here is ratio pages to time in minutes, and our request, we have to determine number of pages in 4.5 hours. So for proportion, we have to use the same units. This is why now, when we will have to write and solve an equation of proportion, we have to convert first 14 pages per 20 minutes into pages an hour. So we have to multiply by 1, which would be 60 minutes over 1 hour, cancel minutes, and then we will have 14 times 3, which is 42 pages per 1 hour. So now we are ready to write out the proportion. X to 4.5 equals 42 to 1. Now cross product gives us 1x equals 4.5 times 42, so x is 189. I skip checking, so we can write out the answer, 189 pages. Early homeowner property taxes are figured at a rate $1.35 tax for every $100 of home value. Find the property taxes on a condominium valued at $247,000. We are looking for taxes. Let's start from the end for our analysis. We are looking for property taxes, so let's mark as a variable x. Taxes on what? On condominium value $247,000. And looking into problem, we can see that ratio taxes to $100 is 1.35 over 100. So now we are ready to write out the proportion. So step number 2, writing and solving an equation. In this case, it will be proportion. So x over 247,000 equals 1.35 over 100. Now, using cross product, we are getting 100 times x equals 247,000 times 1.35. Simplifying. And now we are looking for 1x. We have 100 of them, so we have to divide it by 100 both sides. So x is $3,334.50. I skip checking and just show the answer. It is recommended that there be at least 17 square feet of workspace for every person in a conference room. A certain conference room is 18 feet by 16 feet. Find the maximum number of people the room can accommodate. So we are looking for a number of people. Analysis. Let's start from the end. Find the number of people. Okay, number of people is unknown. We have to mark as a variable x. People were in the room 18 feet by 16 feet. Okay. And looking into our problem, we can see that ratio people to workspace in square feet is 1 to 17. Okay, now we have to write a proportion, which is an equation. So, but we have to use the same units. So first step is we have to find the area of this room. Area of rectangle is length times width. So it will be 18 times 16, and area of this room is 288 square feet. Now step B, we are ready to write out proportion. So x to 288 equals 1 to 17. Using cross product, and we are getting 17x equal 288. But we are looking for 1x. We have to divide it by 17 both sides. So x approximately 17. I skip checking. So write the answer. This room can accommodate about 17 people. Similar triangles. Here is triangle ABC. And then another one smaller. Triangle ABC. Exactly the same shape, only size are smaller. This is what we would call similar triangles. What is very important here in similar triangles? Look, measure of angle A and measure of angle A in smaller triangle is the same. Measure of angle B in large triangle and measure of angle B in small triangle is the same. Measure of angle C in large triangle and measure of angle C in small triangle is the same. Those bars tell us if you see for angle C 3 bars, that means that in both triangles angle C equal. If you see 2 bars for angle B in both triangles, that means they're equal. Now triangles, similar triangles, can be in different positions. So they can be upside down or they can be in slant position. But what is important here, all of those triangles, they are similar. Why? Because they have the same shape. That means angle A, or better to say, measure of angle A is the same for all of those triangles. Measure of angle B is the same for all of those triangles. And measure of angle C exactly the same for all of these triangles. But now, property of similar triangles. If 2 triangles are similar, all pairs of corresponding sides are in proportion. This is what we are going to use. Okay, we are talking about similar triangles. As you see, we have one triangle, ABC, and we reduce this triangle. So we just reduce size, but we did not change shape. So corresponding angles are exactly the same. Angle A equals to angle A, angle B equal to angles B, angle C equal to angle C. And we call this similar triangles. The same, exactly the same shape, only different size. And here is a statement. Property of similar triangles. If 2 triangles are similar, all pairs of corresponding sides are in proportion. So now let's focus on this definition of corresponding sides. Look, here is side AB and it's against angle C, green one. And corresponding would be AB against angle C, green one. Next, BC, brown, against angle A, red one. So corresponding would be BC against angle A, red one. And then side AC, and corresponding would be AC in the small triangle, and both these sides against blue angle B. This is what we would call corresponding pair of corresponding sides. Idea connecting corresponding sides and angles are very important because similar triangles, they can be in very different positions. So sometimes it's not very easy to find corresponding sides unless you know connection with angles. In our modeling, now, if side BC has a length which is 5.6, then length BC in small triangle would be 2 times less. It would be 2.8. And then if AC in large triangle is 7, then in small triangle it would be 2 times less, 3.5. And AB, if this is 4.8 in large, then in small it would be 2 times less, 2.4. They're in proportion. So these two triangles, they are similar, so their corresponding sides are in proportion. Now practical use property of similar triangles. Here is our two triangles, and let's assume that one side, in this case it's BC, is unknown, and we want to find this side. How can we do this? We have to show proportion, and I would start from unknown side, x, and then look for corresponding side in small triangles. It would be 2.8. After that, you can pick any side from the large triangle. I pick 7, and look for corresponding in small one, 3.5. And now you can solve this for x. So we have to solve the proportion. Let's copy proportion and use cross product. What we will have, 3.5 times x equal 2.8 times 7. Simplifying, right side 2.8 times 7, 19.6. And now we have to divide it by 3.5 both sides, because we are looking for 1x. So x would be just 5.6. Length of unknown side is 5.6. This is what we expected, and this is what we have. Similar triangles. Find the missing length. First, we have to identify corresponding sides. What we have? Against angle with 1 mark, and against angles with 2 marks, and then against angles with 3 marks. After that, we can write out the proportion. And I would start from unknown side x and look for corresponding from another triangle. It would be 2.15 equals, and then again one side from first triangle I pick 4, and corresponding from the smaller triangle is 2. Or I could pick left side differently, so it could be 2.2 over 1.1. And then when you have proportion, you have to solve using cross product. So from the first proportion we will have 2 times x equal 2.15 times 4. Simplifying right side using calculator, it will be 8.6, but we are looking for 1x. We have 2 of them, so we have to divide it by 2, and missing length is 4.3. Next problem. Find the length of DE. We have here 2 triangles, but to see better, I will separate them. The first one is blue one, A, D, E, and second one would be red one, A, C, B. And as you see now, we can show size 60 for AD and 160 for AC. These 2 triangles, they are similar. And now we can work on them as on similar triangles. Analysis. First, let x to be the length of DE. This is what we are looking for. Length of AC is 160 because we have to add 160. And because two triangles, blue and red, triangle ADE and triangle ACB, similar, we can work out an equation of proportion. X to AD equals 60 to 160. Now using cross product to find x. As a result, we will have 160x equal 80 times 60. Simplifying right side, 80 times 60 would be 4800. Now we have 160x and we need only 1. So you have to divide it by 160 both sides, and x is 30 now. Checking. Replacing x by 30, and we will have 30 over 80 equals 60 to 160. Is it true or not? You can simplify and you will see 3 over 8 equals 3 over 8. And now the last step, write in the answer. The length of DE is 30. Practical problem. Finding the height of a tree. A tree casts a shadow 18 feet long. At the same time as a woman 5 feet tall casts a shadow 1.5 feet long. Find the height of the tree. Look into drawing and you will see two triangles and they are similar. Small one, red one, and large one,
Green one.
Now we have similar triangles and we are looking for height, h. Let's write out proportion. H over 5 equals 18 over 1.5. Cross product, 1.5 h equals 5 times 18, and we are looking for 1h, so we have to divide it by 1.5 both sides. So now we have h is 60. So now we have height of the tree is 60